So welcome back, guys. So now we'll be moving on to layouts. So this is where we stopped for the last video. We've made this inverter a sub-circuit and more of like an object. So we can now go to the layout environment now. So to do that, for the layout, we're going to be using one of the PDK tools, which is the scheme. So I'm going to be opening a new terminal to call magic. So I go to my desired directory. It's not really part of it, it's just a Linux thing. So hopefully you've gotten used to Linux so far. So and I'm going to be calling magic. So this is how the environment of magic looks like. So when you load magic, two windows will pop up, two windows will come up. This is the first window. Let me show you the second window. This is the second window. This one behind is the main window. That's where your layout operation you'll be doing it. That's where you'll be doing the layout. Why this is a console, a command console. So if you want to enter command, you can just do that. Don't worry, I will explain those commenting later, but just know this, it's like the command console. Then maybe let's just come here. So let's start here. So these are the magic VLSI 2 window, the main window. This is how it should look like. And as usual, you have all these tabs like file, edit, maybe some new kind of tab, cell, windows. You get to know what those tabs are for. Then you have the DRC, that's the design rule check. I told you about rules, some rules you have to follow. So this is like a flagger, so it's kind of it's a flag. Don't know if that English was correct. So if there is any rule being not being followed, maybe there is an error, it will just flag so that you would know and you perhaps just correct it. Then here it's showing the technology I'm using the Skywater technology for my layouts, because eventually I'll be fabricating with the Skywater, with the Global Foundry. This is Global Foundry it's showing. For yours should be showing Skywater. So Global Foundry, that's my technology. Then on this pane on the right, you have some buttons here. They are clickable, yeah, they are, but you can't just click them like that. You need the mouse to be able to click them and paste them here, but all those I'll explain later. But what are these things for? So by now, you from your 351 theory, talking about device physics, now to fabricate a MOSFET. It's made of different layers. You have sorry, I don't have a picture of let me look for a picture of. Okay, so yeah, this is a picture of a mouse. Let's focus on the said mouse. So this is a cross-sectional view of a MOSFET, and this the top view. So this look viewing the MOSFET from the side, and this viewing the MOSFET from the top. More of like maybe your knowledge of ME203 when you're doing the technical drawing. So you have the side view and the plan. The plan view is viewing from the top. So yeah, so and from what you can see the gates. The gates usually made of polysilicon, and the source and the drain. For the NMOS, it's made of an N-type material, N plus type material. Then you have the substrate that is made with a P type substrate. Yeah, so and look at how it looks like from the top, and now coming to magic, we want to do the layout. So for this aspects of design, it's more of the layers of those materials we'll be focusing on. So that's what you have here. These are the different kinds of materials and layers you have for the given technology. This is what the foundry, say for instance Skywater, this, or for mine is Global Foundry. This is what they have available. These are the things, these are the materials and layers available for fabrication. So I can just take you guys through it. Let's error this just to more of, these are like a sample of things you'll be seeing on this main screen. So this is telling you if there is any error in your layout, these are it will appear. Then label, these are label will appear. Subcell, these are how it appear. Deep well, maybe you may not be familiar with all these. ISO substrate, but at least maybe you've heard about N well, maybe. So you, for instance, you need the N well when you want to fabricate the P-type MOSFET, and you need the P well when you want to fabricate the N-type MOSFET. It's maybe kind of counterintuitive, but for NMOS, the substrate is actually P-type. So, and it's like every other things are sitting on that substrate. So that's the idea of the well. So more of like a well. So then every other things are sitting on it. So for NMOS, you need a P well. Most times you start with the P well during fabrication. Then and so on, P base, N base, that's for the BJT. So you have the N transistor, that's the N type MOSFET, and you have the P transistors. So if you have a P transistor on this window, what this is telling you is that this is how N type would appear. This is how PMOS will appear. This for the first one, this is how NMOS will appear. Second one, this is how PMOS will appear. Then NN transistor, I have no idea about that too. Maybe is for another type of transistor though, and so on and so on. Then you have the N diffusion. N diffusion, basically, let me show you this picture again. See, so these are the diffusions, like the materials that are used to make the to form the drain and the source. They are diffusion. They are the materials you call the diffusion. So for the NMOS, you use the N diffusion. So this is the N diffusion. Why for the PMOS, you use the P diffusion. So what this is saying is that this is how N diffusion will appear, it's green, and this is how P diffusion will appear, it's brown like. Then I think maybe this, I've forgotten what this MVN, but it's a type of N diffusion and type of P diffusion. ND contact, this is the contact for the diffusion layer. So ND contact, so N type diffusion contact, that's what it means. So let me give a picture. Why do you need a contact? You can say this is the diffusion, that's what will form the drain, say the drain, and the drain, it's a terminal, so you need to interface it outside so that you can always do the connection, right? So the contact, you don't just place any contact on it, you use a special kind of contact called the N diffusion contact. So, and this is the contact here for the drain side of the N diffusion, and for the source side of the N diffusion, and this for the drain side of the N diffusion. It all does not matter drain source, because most times MOSFET are symmetric. You can interchange what the drain is with what the source is. So this is the kind of contact you use for them, and this for the P diffusion. You can see intuitively, you can see you can see the cross symbol, meaning there is a contact. It's a contact. Almost all the objects here with cross will give you an idea that it's a contact. Then if you look well, you kind of see green streak through the cross symbol. So that's telling you, yes, indeed, that's end diffusion, because end diffusion is green. So that's end diffusion contact. Same thing you can see for the P, it's kind of brown like. Then if you check the strip too, it's kind of brown like too, brown like also. So that's a P diffusion contact. And this for P substrate diffusion. So for the substrates diffusion, and I think the substrate contact should be there. Okay, yeah, and the contacts for the substrate, like for NMOS now, it's formed with a P substrate. So this is the contact for the P substrate. So as you can see, yeah, and so on, and many others. So you can see the gate. Remember, the gate of a transistor is made with polysilicon. So here you have it. So this is a polysilicon. It's red. It's usually red. Yeah. Then what else? Then you have different kinds of metal. You have metal 1, you have metal 2, you have metal 3 and 4, and yeah, and you have, each of them have their contacts. So metal 2 contacts, this is the contacts for metal 2, metal 3 and so on. Also you have what you know, there may be sometimes you want to connect two metals together, two different kinds of metals together. So metal 1, metal 2, for instance, there's a special kind of material you use to connect them. So that material is called that's the I think that's the via 1, and I'm looking for it. Okay, I can't find it for now. Let me, okay, so I can see via 3 here. I can't seem to find that via 1. So for instance, this via 3 helps you to connect metal 1, metal 3 and 4 together. Yeah, that's what via 3 help you to do. You can see via 4 help you connect metal 4 and metal 5 together. And yeah, where is the via 1 and via 2? So via 1, I can't find it yet. Maybe I'm missing the name. But via 1 helps you connect metal 1 and metal 2 together, while via 2 helps you connect metal 2 and 3 together. Via 3 helps you connect metal 3 and 4 together, and via 4 helps you connect via 4 and 5 together. So in global foundries, you have 4 layers, 5 layers of metals, different kinds of metals. All this will get clearer as we proceed. Yeah, what else again? I'm just taking time to introduce you to the whole interface of magic. And you can see the main window, it's kind of blank, and we're going to be drawing. When you're doing layout, it's basically like drawing, you're painting, for those of you who know how to do some graphic work. But no, it's not serious, it's not that much as anything to do with graphics, but I mean, it's just as simple as CorelDRAW, for instance. So basically, when you're doing layout, you're drawing, they actually use the word draw. Yeah, actually. So you want to draw, you need some guiding lines, like margins and all. It's kind of missing here, but we can bring that on. So you just come here, window, then you set the grid. So you can set the grid to any size. The grids will actually basically will be square. So this is just the dimension of the square. So I think for 0.05 micrometer, it's very small. Okay, so good. So data, it looks like I can increase the size to 0.1. You can see, before, look at the former size, 0.05. So this box perfectly fits the grid. Then when I increased it to, let me put the box here. So when I increased it to 0.1, which is half of the former grid dimension, look at it. So you can see the box is half of it. You get, and let me do that. Let me make it 0.5. So 0.5, it's about, I don't know if I'm wrong, if I'm not wrong, about 10 times of it. So you can see it's very small. So if I try to place it here, so you can see indeed it's about 10 times what it was before. So let's just find a suitable grid line. I think the 0.05 for now, it's fine. As you zoom in, zoom out, the grid can look somehow, so you may want to be adjusting so that you'll be guided, you continue to be guided and all by those lines. This is what I'm trying to say. If I try to zoom out, it's getting too small. Then maybe then maybe then I want to increase the grid. So I've increased it so it's better this way. So what else again? So basically, what all this, coming still talking about the left pane here, or sorry, the right pane here. This what we have here. Like I said, when you're doing layout, you're basically drawing, and you're basically painting. So if you've played with CorelDRAW before, you kind of have idea of what we're saying. So for instance, if you want to paint a box, painting, that's what you're doing, but technically that's layout. So if you want to paint a box of, say, size, again, what's this grid line? I think the dimension is 0.1, right? So this is 0.1. So maybe I want to paint a box of dimension 0.3. So I need to cover 3 boxes, right? So all I just need to do is I'll just go to where I would like to draw the box up to. I position myself there, so that's where this cursor currently is. That's where it is in now. Then usually the best experience, you're meant to use the mouse for the layouts, but currently I'm without mouse, so I'll just show you how to use without the mouse. If you can do without the mouse, then it should be easier for you with the mouse. So again, when you just pin yourself at the location where you would like the box to be drawn up to. By the way, whenever you want to draw any box, the box can only go to the top and to the top right direction. This is what I mean. I look at where the cursor is currently, and I want the box to of dimension 3. I can't come here and draw. I can't. Okay, I can. Okay, it's possible. So but generally it's like from corner to corner, kind of. That's how. Let me just come back again and return it back. So if I want to draw a box up to this point here, so I just need to do, after positioning the cursor there, I'll just right click, then the box would be as big as that. Then again, if I want to increase it further, you can just go to the new location and still right click. You don't left click, you right click. If I want to make it maybe wider, I'll just pin myself. Look at it here. So the cursor is currently here. Then I right click again, so you can see the box is getting bigger. Then if I want to move the box, I want to carry this whole box like this, maybe I want to bring it here, you just go to the position you want to, then you left click. So when you want to move, the box can only, wherever you put the cursor, that's where the the bottom left part of the box will start from. Look at what I'm trying to say. So I left click again, you see the lower the bottom part of it on the left just position itself there. So the same thing when I do try to position here again, the bottom left part of the box just comes to start from where the new point is. So that's how to navigate with the boxes. So let's say I want to paint this box red, and you can see that all these materials have their unique color. No other material is kind of repeating, though it can be difficult because it's you have green, different shades of green, but they are not the same thing. So if I want to paint red, I want to paint this red, so that's the polysilicon. The polysilicon is red. Yeah, you can see there are other shades of red. Yeah, that's true. But it still gives the idea that it's a poly. So polysilicon, poly contact, and poly resistor. So it's still a polysilicon, but different versions of a polysilicon. But when you say red, basically it's just only polysilicon. So if you want to paint this red, so when you make the size of the box, how big you want the material to be, then you come here, you select the material. So for our case, it's the red material, which is the polysilicon. If you're using the mouse, you click the middle button. Then when you click the middle button, this place gets painted. My keyboard don't have, my laptop does not have a middle button, so I would have to use a mouse. But if you don't have a mouse, all you just need to do is you open the command window. So I think it's under option, come to option, open the command window. So the window command entry, then you come down here and you tell it paint red, that is, or let's start paint poly. So that is, you want a polysilicon layer around that, filling that box area. So you hit the enter key and you get to see that you have a poly material here. You maybe you want to do the same another position. So you want to paint this place poly, maybe you need a polysilicon material here. You can just come again and you say paint poly, or like I said, you can use their colors. So red for polysilicon, so paint red. What's the issue? It's not okay. So I can just check any error. It's getting too much, so let me use this. Then it seems the new update does not take the color anymore, but you can actually use red, but maybe the new update. So it's all fine because the colors, as they are doing the updates, the colors are getting alike and also, yeah. So you, for the safest bets, you just use the name of the material you want to draw or you want to lay out. So that's how to go about it. So let's say we want to paint the end diffusion kind of material. We want end diffusion to be filled, this box to be filled with end diffusion material. So again, you just come, you say paint. So what's the name? So the end diffusion, so end diff. So you can use the short form, I think, too, if you don't want to type the end diffusion, that is end diffusion. So end diffusion, you can use their short, just like the poly. I just use poly, I don't put polysilicon. So the same thing, you can use the short form end diff. So I think it will still get painted. So that's it. Yeah, and so on, and just watch and see. So remember, it's to make an NMOS, you need, what are the materials you need? Let's come back here. you can see the diffusion, the end diffusion here. You can see the gate. The gate is usually made of polysilicon. Then you can see the substrate. So that is, with these materials I can form an NMOS. So to do that, so since I have the end diffusion already, so if I bring let me come back here again. By the way, for the layout, it's the top view we're going to be the layout assumes the top view, not the side view. So this is how it look like. So this, whenever we're doing the layout, this is what we'll be seeing. So you can see the gate. The gate is over the diffusion, and I mean also the substrate. Then you can see the diffusions here, the source, this area here, the drain, those are the diffusion. Then this one beneath the diffusion, that's the substrate you get. So that means if I place a poly over the diffusion, then that should give me just basically an NMOS. So let's just try that out. So I just need a slim gate, not so wide a gate. So I want to reposition. So maybe to delete, so I need something slimmer, so I can just delete this material here. I need something slimmer. So when you place the box over the material, I think the D, you hit the D button on your keyboard, that should delete. Okay, maybe it's not selected yet. Let me try the S key to select, then D for delete, so it's off again. Let me do that again. You place the box around the area you want to delete, then you hit the S button on the keyboard for select, then it's selected. Next thing, it's you hit the D button for delete. So I need, like I said, I need a slimmer gate. It's in a slimmer gate. So this box is too big, the dimension is too big. So let me just make it as slim as, just 1, 2, 3. So I will just position here, then I right click, then it becomes like slimmer. Then I want it to be longer so it can overlap, longer than the width of this diffusion here. So I come again, I still want to make it longer. I position, I place the cursor, I position the cursor, then I right click. So then I can now bring the box over the material, then position it the way I want. I think I want it to be a bit symmetrical, so I will make the box longer. So now this is symmetrical. The overlap, it overlaps by 2 boxes, even here 2 boxes, left and right, so it's all symmetrical. So I would now go ahead and tell Magic to paint poly. So we need a polysilicon poly, so you can see. So look at the changes that happened. Suddenly this area, the shade changed. So you have like stripe, green stripe, then a brown kind of background, right? Then if you come here, let's check which material matches this pattern. So checking, this is the material that matches. So you can see the brown background, then the green stripe. So that is, and it's called what? N transistor. That's the NMOS. So that we've basically formed an NMOS here. So that way you can see this is an NMOS. So this is your NMOS basically, but yeah, maybe the performance and all, it may really not be a good one, but basically this is an NMOS that you formed. Then let me just check the time.